Hello everybody, how are you going? And welcome to the supposed largest impact crater on the planet, hidden in Australia, the Deniliquin structure. Now, I have never heard of such thing. It's never been mentioned in any textbooks that I've ever read. I've only ever heard about some big ones up in Canada, maybe in Russia, and then of course, I believe it's over Mexico where the dinosaurs asteroid landed, but nothing in the middle of the outback, anywhere close to here.
Due to a new scientific discovery, the largest impact crater on the planet may have just been found within mainland Australia. But if the reported feature is truly an impact crater, its existence raises many more questions. This is the story of Australia's Deniliquin structure. For several years, people who looked at the available aeromagnetic maps of Australia, which display the variable abundance of magnetic minerals in the Earth's crust, might have noted a large and circular region which contained less magnetic minerals than the surrounding rock.
Hang on. Alright then, I just want to be trying to figure out what I'm actually looking at here, because you can say that it has lower values, but what are we talking about here? He said something about the magnetic contents of the geology, I can only presume, but what is the scale? Is it just in metric tons? Is it in parts per trillion of, I don't know, cubic centimeters? What are we looking at here? Because I've never seen such a map, especially considering it's certainly not like a mountainous map. The east coast would be much more mountainous, and all the kind of coastline would be more mountainous compared to the inside as well, and that's certainly not what is happening here. I mean, I can only presume that when he is talking about magnetic materials, he is meaning things like iron ore and all those massive deposits that are littered all around there, because that chart definitely lines up with where a whole bundle of mining is. But what confuses me the most is the fact that the purple areas, which according to the chart is nothing, are right next to where the maroon areas are, right next to everything. And so is that just not, I don't know if you'd call it tectonic plates, but geology just pushing these, I guess they're not mountains, but are they just underground mountains and deposits around all over the place and just depositing them in these massive bands? Or how else do they get formed? I mean, I could understand if it was red and purple and gradient of yellow and green between that, but why they're just suddenly up in Cairns and up in Cape York and all these areas, just massive bands of yellow and kind of zero, not minus 150, but zero.
And at the edge of this feature, there appeared to be a structure likely 200 kilometers in diameter, which had a higher concentration of magnetic minerals than adjacent rock. Due to how much of a perfect circle this region represented, some scientists suggested that it might represent a buried impact crater. After all, such magnetic surveys have been used for several decades to discover buried impact structures which might otherwise go unnoticed.
Wow.
For example, the exposed lunar impact crater in India displays the hallmarks of such a structure.
Look at that. That is just so pretty. I mean, it's also such a devastating event and such a colossal kind of unimaginable scale when you're having these things, like I said with the dinosaurs crater. When you have an object with that much energy, you cannot fathom it. We have a nuclear bomb, but it doesn't even come close. It's not even in a realm of possibility. And so I can only imagine that something like this, it would be similar to a nuclear bomb, probably a little bit more powerful than a nuclear bomb. I guess I don't really know the size of it. Actually, I can see a little bit of a hut down there. So it's a little bit bigger than I expected. So it's probably got a decent crater size behind it, because that's the crater, not even just the size of the actual impact and all the debris that got launched out of everywhere. Coming back to this one though, I'm just trying to dissect what he is talking about in terms of it being a perfect circle. As I mean, I guess they did say they can be buried, and so modern day satellite imagery isn't going to be particularly revealing of anything if it is just going to be a massive underground, sort of say, substructure. But how do you even go and see that that is a circle? Because to me, it doesn't look like a circle. Maybe they have a bit higher resolution in this mapping, but that's literally just, I don't know, a burger with a bit on the side. The beetroot fell out of the burger. I don't know what you'd call that. And it's a 200-kilometer wide structure in higher value. So how do you go from it being maybe a crater or maybe just mountain ranges and how the entire thing formed in just luck more than a meteor? I have no idea. But hey, there are some very smart people with some very expensive equipment that probably say that this is what it is, or very well likely could be.
In its center is a decreased amount of magnetic minerals, while its rim contained a temporary increase. Due to the resemblance, a new higher quality magnetic survey was performed within New South Wales and Victoria. This study, which was published in 2022, not only confirmed the existence of this ring structure in higher detail, but also found another even larger ring measuring 520 kilometers or 323 miles across.
Hang on. Okay, well, I was wondering why the circle looked small in comparison to some of the other circles that I've seen being impact craters, like I said, around Mexico and whatnot, but that I guess if that's not the impact crater, but you have the impact crater, which is massive, 1,000 kilometers across, and then you have the shockwave crater. I don't know the official terminology of it, but if that's an official crater compared to the impact point, that is a large piece of rock falling out of the sky, and certainly not the biggest, and probably not the biggest that Earth has ever seen or ever could see in terms of possibilities. But my goodness, that thing would not be good for anyone living anywhere in the world, let alone anyone in Albury Wodonga. It doesn't matter. You'll be instantly vaporized, but basically the entire planet's surface of people will too. And this kind of thing also does make me wonder, especially when I see this red Earth imagery, and even just coming back to this original one, could these massive deposits be the remnants of a giant meteor? Because meteors are generally very, very element heavy. There is plenty of surveys out there that show if we go and mine that particular asteroid and that particular meteor and all these different things, they are way more element dense than a lot of what Australia or anywhere in the world particularly has. And so is that why some areas are particularly more element dense? Because they could just be impact points and just scatterings of all these meteors that impacted Earth really early on, and then also obviously originally combined and got melted to the surface. There are all that stuff that just makes you wonder how much is truly kind of domestic and how much is alien.
This study, which was published in 2022, not only confirmed the existence of this ring structure in higher detail, but also found another even larger ring measuring 520 kilometers or 323 miles across. This structure is known as the Deniliquin structure, which is named after its approximate center near the town of Deniliquin in New South Wales. It encompasses a vast area which stretches all the way down to Melbourne in the south, Robinvale in the west, Hillston in the north, and Albury in the east. This suspected impact feature is not only the largest impact crater in Australia, beating out Bedout Crater, but also the largest impact crater in the world, comprising a little more than 2.5% of Australia's landmass, with a little more than 14% of the country's population living within its rim.
Just because of Melbourne, which is utterly insane, and I am still wondering why even in here he didn't mention anything about the impact crater or the impact event from the dinosaurs extinction, which doesn't make sense to me. I've always known that to be the biggest. I thought it was like 2,000 k's across or something. That's just a number that I'm plucking out of my head, which would clearly beat all of these other guys. I mean, I never knew about this one, which is, I guess, not confusing, and just that the water levels would have been completely different, but my goodness, to have an impact crater now in the middle of the ocean, I wonder if you can see that from Google Maps. I mean, I'm never too sure how accurate all this data is in terms of the darker and lighter areas and all the plate tectonics, and obviously if you come up to the Mariana Trench, it's very, very dark, but I don't particularly see anything super prominent, not a perfect circle by any means. Maybe that, I don't know exactly where it was, but he said it was just up here and I don't see anything. However, you can also see, if this is correct, where the landmass truly is and how people were able to cross all the way up into Papua New Guinea and Indonesia and have this huge area, even obviously just able to cross down into Tasmania and just by foot via the Bass Strait. And I remember hearing that, yeah, look at this, New Zealand's landmass, so to say, is actually massive. It's this huge bit up here that almost extends up into Fiji, but obviously this is also where it allows the impact crater to actually hit soil and not water originally. And I just couldn't help myself, my curiosity was getting the better of me, but there it is. The Chicxulub, I believe, is something like that is how it's pronounced. Crater, impact crater, with an asteroid that was between 10 and 15 kilometers wide, but of course the impact crater was much wider, but only 150 kilometers in diameter. Wow. I guess this is the kind of imagery that I've seen previously, and so I'm thinking that it's thousands of kilometers across, and it kind of always seems like it should be in a way, but then I guess when you see a little image like this and you see the actual crater size compared to what we are also talking about in the middle of Australia, that thing looks tiny. Like, the other one is 500 kilometers across, not 100. Massive area.
So, what evidence other than high-resolution magnetic surveys do we have? For one, the 200-kilometer wide ring, which initially rose suspicions, was not the outline of the entire impact structure, but rather represented only the diameter of its innermost ring, within which is a central peak. Why is this evidence important? Simply put, at every single impact crater larger than 4 kilometers in diameter on Earth, material during the impact will be pushed towards the center and then pushed upwards, being a hallmark of what is known as a complex crater.
Why? I'm trying to think why that would be. Is it because it's such an instantaneous point of impact that I guess the equal and opposite reaction just forces it upwards with such incredible momentum that it does that long term, and then of course it has its secondary ring as well once that settles. But man, I hope he explains it. I mean, I've seen this kind of imagery before as well, but this Deniliquin structure is
Why
so
is this
massive.
evidence important? Simply put, at every single impact crater larger than 4 kilometers in diameter on Earth, material during the impact will be pushed towards the center and then pushed upwards, being a hallmark of what is known as a complex crater. Also, there appears to be a notable ring surrounding the Deniliquin structure's outer ring, which is most notable via the location of a series of lakes north of Mosgiel. Since this suspected structure is buried by more than 10,000 feet thick of rock, it should come as no surprise that it is suspected to be more than 400 million years old. In fact, the Deniliquin structure is dated to somewhere between 417 and 525 million years in age. If this is indeed an impact crater, it goes without saying that much like the 180-kilometer wide Chicxulub crater that wiped out the non-avian dinosaur 66.04 million years ago, the vastness of the Deniliquin structure certainly implies that whenever it formed also created a deadly mass extinction event.
Absolutely. There was no way that anything is surviving that, like we already quickly saw, and then he obviously also recapped the 180-kilometer wide one was a massive extinction event, unlike anything besides another great extinction event that we previously kind of learned about. And then for the Deniliquin structure to be way bigger, of course way older, kind of before, am I right in thinking kind of before any organisms? And could it have been a catalyst in terms of putting heat into the atmosphere and actually making an atmosphere? I don't know. It's all speculation on my behalf. I'm sure some people would know. But this structure is just so massive, and I want to just confirm, I believe he said 10,000 feet low.
Since this suspected structure is buried by more than 10,000 feet thick of rock.
10,000 feet, 3 kilometers? Wait, really? 3 kilometers down? How do you have 3 kilometers worth of deposits on top of the earth of that impact crater? I don't get how you can have that much rock moving on top of itself in 500 million years, especially since the earth has been not in its original building phase in that time. And so, man, that's very impressive. I mean, I also do want to be trying to see what these impact lakes are, and if it is 3 kilometers deep, why are there lakes? Or how do the lakes come into it? Is that just massive impact scars and stuff? I have no idea. It's just so blowing my mind that this thing is just in the backyard, so to say, especially in Melbourne's backyard, and no one ever knew about it, or none of us ever knew about it. It's not like you get taught about it, like, yes, here we go, let's go on an excursion to the biggest crater possibly in the world. And I certainly would not say that my statement of nothing was really around 500 million years ago is correct, but reading this, I also wasn't particularly including single-celled organisms found in the Pilbara. At the same time, it's also crazy to me that these are 3.5 billion years old, and yes, the dinosaurs were 60 million years old, but that is such a huge difference in time that the 500 million years ago crater was surely not the first thing that these organisms were having to deal with. There are going to be so many impacts and meteors between the 50 million year and the 500 million year one being two major extinction events. How are we only just still having single-celled organisms this entire time? And how are we even here when you hear about some of this stuff?
During the current estimate we have for its age range, 6 minor mass extinctions and 1 major mass extinction occurred. The major mass extinction is known as the late Ordovician mass extinction and is considered to be the second deadliest mass extinction in Earth's history, where 443 million years ago 85% of all the planet's species went extinct in a brief period.
How crazy is that? It's just insane to think all the possibilities that we could still be having, and I guess one thing led to another, and the fact that 86% of species went extinct 444 million years ago, and then 96% of species went extinct 256 million years ago, and then 76% of species went extinct 65 million years ago. With all of those percentages stacked up, can you imagine the amount of competition on this planet at this point in time if nothing really happened? Maybe there also wouldn't really be any competition because one thing would have just evolved beyond everything else, beyond anything, and we just would all be gone because it just would have taken over more than any human could ever possibly begin to compete with. But the fact is, so many of these things, look at this, end of the Triassic, 80% of species, late Denovian, 75% of species, there were just so much more possibility in biology for so many other things, and it's so narrow these days. I mean, the world is full of incredible creatures, but my goodness, the possibility of biology is endless. Also, even the fact that you can even call something a minor mass extinction just boggles the
and
mind.
It's considered to be the second deadliest mass extinction in Earth's history, where 443 million years ago, 85% of all the planet's species went extinct in a brief period. This was associated with both falling sea levels and an ocean which suddenly became largely devoid of oxygen. As a reminder, the element iridium is more common in asteroids because these largely represent poorly differentiated bodies than in the Earth's crust, as on Earth the vast majority of iridium long ago sunk into the Earth's core. Thus, if an impact event was to have occurred, a distinctive layer of iridium-enriched material would have settled around the planet via what is known as an iridium spike. Yet, thorough searches have been performed on the planet's rock units, and no iridium spikes were found at the layers representing the time of the late Ordovician mass extinction event. So, if there is no iridium spike, is it possible for this structure to be truly an impact crater?
Wait, what? Wait. I don't even know what he just said. Trillion impact crater. The universe isn't trillions of years old, not anywhere near that old, and that's now confused me. I might have to listen to it again, but I just wanted to come back and just break this down because iridium is such an element that there's so many elements that you never hear about, but it makes sense that it's just going to be located basically out of our reach. I mean, we barely scratch the surface. We do a pretty good job of scratching the surface, sometimes too good of a job, but as an entire body of rock, the planet doesn't care. It doesn't even notice a tiny little infringement, barely a scar in the entire mass of this massive monstrosity of a planet, or honestly not that big, but on our scale it is. But the fact that the oceans were then devoid of oxygen, I don't know how that works. Is it just getting superheated to the point where, I don't know, where is all the oxygen going? Every time you watch one of these videos, unless you've just got a PhD in history and in archaeology and geology, you just get left with so many more questions. It's painful and awesome at the same time. And look, I have read the little bottom paragraph, and to my understanding, it doesn't particularly say anything about what this is in particular. I can only presume that he's put this in here because it relates to another impact that shows that this kind of thing does occur. And it does say from Cretaceous, there's actually a hyphen there, but Cretaceous tertiary boundary clay, whatever that particularly means in terms of an impact and a layer within all the crust. But if nothing else, I can certainly see with my own eyes, unless the image is an AI or photoshopped image, that there's a different color there, and that's caused by something. If nothing else, even if you didn't know what it was, you go, that is different to that.
So, if there is no iridium spike, is it possible for this structure to be truly an impact crater? While the evidence we currently have does support the assertion that the Deniliquin structure is an impact crater, it is far from conclusive.
Right.
Conclusive evidence would include finding shatter cones or what are known as shocked quartz.
Oh, well, that other little video has also caught my attention in terms of the impact crater in Lake Superior, the Slate Island, so I'll have to be checking that out. But even after seeing something like this, even though it's not conclusive, at the same time, it does make you excited. Just going, like I said, the scale of surveying and imaging on that level, it just blows my mind that you can even image something that massive on the Earth to that fine degree, and not just shooting a satellite down and go, okay, there's an image. No, it's 3 kilometers deep, I believe. 10,000 feet should be about 3 kilometers. And then you're looking for all these other particular evidence, from normal quartz to shock quartz, and then even the shatter cone, of which I have no idea what that is, because if you said that is an image of something relating to an asteroid, I would go, that's either a piece of the asteroid or it's the splatter spree of what the asteroid does to the ground. Like, that's a massive satellite imagery in, I don't know, infrared or something. It doesn't even matter, but how big is this thing? I have no context. There's no graph as far as anything I can see, no scale. And so what is it? It's shatter cones. I'm like, you need to be describing this stuff. You can't just leave me on edge like this. And so look, even though we did sum it up by saying it's far from being conclusive, at the same time, when you see these concentric circles and you look at some of the other areas around the planet that obviously have had impact craters before, you know, if this was the first and only one that Earth had ever seen, then it probably wouldn't even be on people's minds. But when you see some of the other things that have happened to Earth, and that kind of time period that Earth's entire timeline works on 500 million years ago, who's going to say it? It's not like you can just write it down in history books. No, it could certainly be that. And if it is, that's cool, because, I mean, it's in the backyard of Australia. Australia, like I said, has a lot going for it. 3.5 billion years ago, microorganisms, all the dinosaurs that are more modern than that, so to say, in the grand scheme of things. And then even this, it's just all in the backyard.